Hello there. I thought I'd give you a quick bit of instruction on the Bellwork on section 4.4 over graphs of sine and cosine to help you out a little bit today in my absence. The first one asks us to find the amplitude and period of y equals -4 cosine 3x. The amplitude you will always locate in front of the trigonometric function. Here the amplitude is 4. Amplitude is always positive. Okay, so the fact that it's negative doesn't matter. For the period, for sine and cosine graphs, you always start with a period of 2 pi and you divide it by the coefficient of the x. If any reducing is required for that fraction, you will reduce it, but in this case, it's already in a reduced form. So here is our amplitude and period finished. On the next one, 1b, you have an amplitude of 6, and you have a period of 2 pi divided by what's in front of the x is the fraction pi over 4. That's equivalent to 2 pi times the reciprocal of that denominator, which is 4 over pi. What happens now is that the pi's will cancel, so we are left with a period length of 8. Next one asks for the viewing window for the function y equals 2 sine 2x. What I mean by the viewing window is what is the bottom y to the top y value, and what is the furthest left x value and the furthest right x value. So what is the picture of the graph that we're looking at? And so to answer the question about the y's, we're going to look at the amplitude of the function. The amplitude of the function is 2. So if we count the tick marks on the y-axis, we see 1, 2, 3, and 4 tick marks, and the second tick mark is the amplitude value of 2. So if that second mark is 2, that means this graph goes down to 4 and it goes up to positive 4. So the y value window range is -4 to 4. Now for the x range, we're going to use the period. The period is 2 pi divided by 2, which is pi. So what I would do is count how many periods do we have in this graph. Starting at the origin here, goes up, down, back up. That's one period length. That's the length of pi units. And then we see it again. That's another pi. And again, that's another pi. And one more time to right there. So that went 4 periods out. Each period has length pi. 4 periods times pi is 4 pi. We see the same length out to the left. So our x is -4 pi to positive 4 pi. The last problem here asks us to sketch a graph of these functions. So the first one, -3 sine 2x, let's do that one in blue, has an amplitude of 3 and a period of 2 pi divided by 2, which reduces to simply pi. So this graph is going to take on all of its values from 0 to pi units. So I'm looking 0 to pi. It's a sine graph. Sine graphs start at the origin. So there's its first point. Has an amplitude of 3, but it's going to go down first, and then back to 0, and then up its amplitude, and then back to 0. So the idea is that we're going to see the entire curve from 0 to pi. That's one period length. Now if we want to see another period, we can graph the same pattern. Down its amplitude, back to 0, up its amplitude, back to 0. And we see the same curve. And of course we can go to the left as well with the same pattern. Just follow the point pattern. Go ahead and do one more period. So about like that. The other graph, let's do this one here in green, has an amplitude of 2 and it has a period of 2 pi divided by 1/2, which would simplify to 4 pi. So it's a cosine graph. Cosine graph starts off the origin, so it's going to start right here at 0, 2, and its first point, okay, so let's think of a graph like this. If its first point is off the origin here, and then it's got another one at the 0, then it goes down, then it goes back to 0, then it goes back up, and it finishes. So here's what this cosine graph looks like. This value here is 4 pi. So let's figure out what the rest of these values are. This value is 2 pi. This value is 1 pi. And this value is 3 pi. Well, our graph only goes to 2 pi. So our graph is only going to show from up to the 2 pi. Our graph is not going to show any of these points out here because the graph's just not big enough on the scale. So we're going to start at 2, and then notice we return to the x-axis at pi. Well, that's right here. I can get it to show. And then it goes down its amplitude here at 2 pi, about there. So it's going to look kind of like this. And then from that point it would turn and go back up. And it's going to do the same thing on the other side. About like that. Okay, so there's these two functions graphed on the same grid, so we can kind of see the difference in amplitude and period and how it affects the appearance of the graph. Alright, there you go. Good luck on your 4.4 assignments today.